All right. Hey, everyone. I'm David Watson again.
Hi, I'm Rachel Curian.
And today we're talking about measures of variation. So measures of variation are used to measure the spread of data. All right. So last time we talked about mean, median, and mode. Those are used to find different interpretations of the middle of the data. Right, either by averaging it or finding the most common data or just literally finding the middle. This is used to figure out how far data is spread out from each other. All right, so the first way to do that is the range. So the range for a data set is found by finding the difference in the highest and lowest data values. All right, so all that means is you take the highest and subtract the lowest. That's it for range. And the other one that we're going to talk about today is the standard deviation. Okay. So this is just another measure of how spread out the numbers are. Right? The way it figures it out is it looks at how far away are they from the mean of the data. Right? And there's two different versions of this. There's population standard deviation and there's sample standard deviation. Right? Population is for if you have the entire population. Sample is for if you just have a small sample of the population. All right, there's two different formulas for it. They're both really similar with just one difference. So this first one, the population standard deviation is called sigma. That symbol right there. And it equals the square root of the sum of each data value minus the mean. So mu is the population mean. So you take the difference between the data value and the mean, you square it, you do that for each data value you have and add them all up. Okay. N, that big N down there, is the number of data values you have. All right. And then you take the square root of all of that. All right, we'll see that in a little bit. The sample standard deviation is really similar. All right, so it's just small s and equals the sum of each data value minus the sample mean. So this x bar is the sample mean. So you're still finding the mean each time, just ones of the sample, ones of the population. You're still squaring those differences, adding them all together, and this time you divide by n minus 1. So n is, again, just the number of data values you have. In this case, in the sample. Okay, but this time we subtract by n minus 1. All right. Now the reason that we do that is statisticians have showed that n minus 1 gets you closer to the population standard deviation than just n. All right, so they use statistics to figure out more stuff about statistics. All right, so let's start looking at some examples. Do the first three by hand, and then we're going to move over to Excel. So first off, find the range of the test scores. So remember, range is you just take the highest and subtract the lowest. So 96 right here. That's our highest. 19, that's our lowest. So if we just do 96 minus 19, that would get us 77. That's our range. That's it. That's all you have to do for range. All right. Let's go on to example 2. This time we're finding range in population standard deviation for each set. All right. This second one over here, don't worry about this one yet. We're going to do this one in Excel later. But for this first one, first let's find the range, because that's the easy one. Oh, why did it just move that down? So again, we just do highest, so 22, minus the lowest, which is 16. So that gives us 6. That's our range. All right, now let's take a look at standard deviation. All right, so to do this, we're going to make a little table. Right? Our first column is just going to have all of our x values. All right, so we're going to have 16, 18, 19, 20, 22. Our next column is going to have our x values, and we're going to subtract the mean. Now, if we need to subtract the mean, that means we have to find the mean, right? So how do we find the mean? Well, we just add them all up, divide by the number there are. So it'd be, let me just do this right up here. So the mean, mu, is just going to be 16 plus 18 plus 19 plus 20 plus 22. All right, we're going to divide that by the number of data. In this case, we have 5, right? So if you just put that in your calculator, you should get that the mean is 19. So when I say x minus mu here, I really mean x minus 19. So we're just going to do 16 minus 19. That's going to get us negative 3. We're going to do 18 minus 19. It's negative 1. 19 minus 19 is 0. 20 minus 19 is 1. And 22 minus 19 is 3. All right, just one more column. Last column is going to be x minus mu squared. All right, so what that means is we're just going to take those numbers we just found in the middle column, and we're just going to square them. So negative 3 squared would be 9. Negative 1 squared would be 1. 0 squared would be 0. 1 squared is 1. 3 squared is 9. Now, if you remember in that formula, it said the sum of all of those squares, right? So at the bottom, I'm just going to put sum. And if we add up the last column, we get 20. All right, that's going to be the number we're working with. It's that 20 right there. So our standard deviations, sigma, is the square root of the sum of x minus mu squared all over n. That top part, the sum of x minus mu squared, that's what we just found right there with the table. All right, so it's going to be the square root of 20 over n. Remember, n is just how many values do we have? Well, we had 5. 20 divided by 5 is 4. And the square root of 4 is 2. So our standard deviation is 2. All right, let's try another one. So example 3. Find the range and standard deviation of the shirt sizes of a sample of 8 children in a classroom. All right, now keyword here is sample. So we're not doing population standard deviation this time. We're doing the sample standard deviation. All right, but we're going to do it the same way, just it has some different variables. All right, so if we start this off, we're going to make another table. So we start out with x, which is just our values. So it's going to be 8, 8, 10, 10. There we go. 10. Why is it doing this? Sorry guys, my pen's messing up a bit. There you go. 10, 10, 10, 12, 12, 14. The next one's going to be x minus x bar. All right, so this x minus x bar is really similar to the x minus mu. X bar is still just the mean, but it's the sample mean this time, so it has a different letter. So if we want to figure out what x bar is, again, we just add up all of the numbers, divide by how many there are. So 8 plus 8 plus 10 plus 10 plus 10 plus 12 plus 12 plus 14 all over 8. That'll get you 84 over 8, or 10.5. So this x minus x bar really means x minus 10.5. All right, now hopefully all of you have your calculators handy because you're going to need them for these. All right, so first off, we have 8, get a different color, 8 minus 10.5. So that would get us negative 2.5. We have another 8, so that's again negative 2.5. We have 10 minus 10.5. It's going to be negative 0.5. And again, these other 10s will be the same thing. 12 minus 10.5 will be 1.5. So another 1.5 there. Lastly, 14 minus 10.5 is 3.5. All right, the last column, x minus x bar squared. So if we square each of these numbers, negative 2.5 squared is going to be 6.25. Negative 0.5 squared is going to be 0.25. 1.5 squared is 2.25. And 3.5 squared is 12.25. Now remember, we need the sum of all of those. So if we just add up everything in that last column, we'll actually get a pretty nice number. It's just 30. All right. So our sample standard deviation, S, is the square root of the sum x minus x bar squared all over n minus 1. So our sum up there was 30 over n minus 1. So our n was 8 because there was 8 data values. So n minus 1 would be 7. Throw this in your calculator at this point, and you get approximately 2.07. That's our standard deviation. All right. And one last thing I do want to mention real quick. So if you do take away this square root from either the population standard deviation or the sample standard deviation, you get something called the variance, right? So variance is just standard deviation squared. So it takes away that root, right? We're not going to make you calculate it or anything like that, but just fun little fact to keep in the back of your mind. All right, with that, I think we're ready to move on to Excel. So I'm going to stop sharing my screen. And Rachel, you good to go?
All right, so here we have, I'm going to try to put the problems and everything together. Okay, so here we have example 4, and it's a sample of 5 salaries for the workers in a small company. And we want to find the range and the standard deviation. So I already have the data listed out. So it's right here, the data. So to find the range, don't forget it's the biggest minus the smallest, or the highest minus the lowest. And in Excel, we're talking about the max, that's the biggest of this data, minus the smallest, which is the min. You highlight it again. And we should get the range. And why do you think our range is so high? Well, it's because of this 240,000 in there that kind of throws everything off. All right, next one is standard deviation. And we're talking about just 5 salaries. Not everybody that works there, just 5 workers. So we're looking at the standard deviation for the sample. So you see the ST, that's standard deviation, DEV. dot S. That is your sample. So we're going to highlight it, and then we'll close the parentheses, and voila, we get our standard deviation. And that's it. That's the end of it. I know, a lot quicker. All right, so let's look at number 5. Again, we want to find our range. So we're going to do the max, that's your biggest number, minus your min, which is your smallest number. And there we have our answer. So the range is 4. Now we want to find our population standard deviation. So we're going to hit equals. And once you type in ST, you'll see a bunch of stuff pop up. Just click on the second one. It says .p on there, and it's for your population. So highlight everything, close the parentheses, and hit enter. And you get your answer. All right. Last one is number 6, and we want to find the range and standard deviation for a sample of 25 student grades. So let's find the range first. Again, it's max. That's your biggest number out of this data set. Minus the min of this data set. And then close the parentheses. And you get 59. And so now we're going to look at standard deviation. And it's for the sample. So I'm going to type in ST. Keep in mind it's a sample of 25 student grades, so you're going to hit the dot S. Select all your numbers. And then close the parentheses. And hit enter. So the great thing about Excel is that it moves quickly, like you can calculate everything. The bad thing is that you have to make sure that your data is correct, because just changing one number changes your standard deviation. So just be careful on that. And with that being said, that is the end of our lesson.
Hi, guys.
Bye.